Hello, my name is Varun and I'm here to introduce the new entry-level student FPGA board from Digiland, the Basys3. The Basys3 has the Xilinx 7 series FPGA, the Arctic 7, designed specifically to work with Vivado design suite. The Arctic 7 FPGA is optimized for low cost, low power, small form factor. This is the Vivado start page and you can create the new project. You can choose the location of your project and make sure that there are no spaces in the project location and the project name. Let's call this Basys3 intro. This is an RTL project. We do not specify sources at this time. Choose your FPGA family part numbers. You can go back to the Basys3 board screenshot. You can zoom in and look at the part number, the family, the device number, and the speed grade. Using this information, we go back into Vivado and select our FPGA. The package number would be CPG236, speed grade 1. And between the two final options, the first one is our board. This will create your project and give you the main Vivado tool homepage. You have your flow navigator, the project summary, and the design runs console. These are the three main windows in your homepage. And the flow navigator is used to create your block design, add sources, run simulation, start your synthesis, implementation, and also create your bit file, and then program it using the hardware manager. The project summary will give you the status of your project. Let's start with adding constraints. Vivado uses XDC constraint file. That's a Xilinx design constraint file. Add the XDC file and choose the pins, ports, and objects and signals that you want to activate for your design. So let's go to add sources, add or create constraints, add files, go to the location, and also make sure there are no spaces in the XDC file name. OK, finish, and this would bring up the master XDC file. Next, let us add the design sources, which have been pre-built in Verilog HDL. These are my pre-built source files. You can select all of them together and import them into your project. You can note that by checking this, it would copy all the source files into your project location that you had just created. So you do not have to edit or change the original source files if you have to go back to them and use them again for a different project. And the project manager will add all the different sub-modules, the different Verilog modules here. All these different modules are connected to the top module. And taking a look inside the top module, you can see the top module inputs to the board and the outputs, the input clock, the 5 push buttons, the 16 slide switch inputs, 16 LED outputs, and the 7-segment display output. So these are our top module input and outputs, and once you go back to your master XDC, you will find the same port numbers and pin locations and pin names. Make sure that the name of the input and the outputs match with the pin names that you have in your XDC. So my clock signal is named clock CLK, switches as W, LEDs as LED, and the 7-segment display as SEG. So you can take a look, SEG, AN, and DP. So, and the push buttons BT and C. This is the valid pin name. So you should have the BT and a capital C or a capital U. You can select all the signals that we need for our design to this point and activate them by uncommenting them. check your XTC file for any non-pin information that is something that's supposed to be a comment that is not commented properly. Make sure you have no errors there. Save the file. Now let us begin the process of programming the FPGA. There are two ways in which you can program the FPGA. One is using the bit file. We use the JTAG programming cable to load the bit file into the FPGA. The second method is programming the FPGA using the QSPI. For this, we need the .bin file, the binary file, to be loaded onto the QSPI. And when you turn on the FPGA will load the programming file from the QSPI, and you don't have to go through loading the bit file through the cable. So what you need to do is go into Tools, Project Settings, Synthesis, Implementation, and Bitstream information is here. You can go into Bitstream and check the bin file. So this bin file, the binary file, allows you to add a memory configuration file into your FPGA flash device. And when you do that, once you power on your device, you can just directly run your project and you don't have to program the FPGA all the time. For this, let us set some device properties beforehand. To edit the device properties, this can be done in the Synthesis Design Open window or the Implementation Design Open window. So instead of generating the bit stream at one go, let us run the synthesis first. This will generate both the bit file, the .bit file, and the .bin file. The log window is a good place to get a lot of information and find out which design run you're in. Now the synthesis has successfully completed. Let us open the synthesized design. In the synthesized design window, head over to Tools, Edit Device Properties. Check for the bitstream compression setting, it's true. Configuration, change the configuration rate to 33 megahertz. This is the reliable, consistent configuration rate for the board. Head over to configuration mode. Choose the quad SPI mode. Close the synthesized design. Save the synthesized design. And now you can head over to the program and debug section and generate the bit stream. Over here you can take a look. It says the bit stream, .bit file, and the .bin file have been generated successfully at the same time with the device configuration settings that we have just made. Open the hardware manager, open new hardware target, click next, make sure the device is turned on, next again. You will see the FPGA part number at this place. Change the JTAG clock frequency to 30 megahertz. Select your device, click next, finish. The device is ready to be programmed. If you can take a look at the board, the jumper is set to JTAG programming mode, and in that mode you can program the device using the top module bit file. The top module bit file gives you additional information on when it has been created, the date and the time. This is handy information when you have multiple bit file generation done within the same project, so you can keep track of which bit file is the most useful one if you had to go back and make edits into your source files. So click OK and program that. Now the bit file is programmed into the FPGA, and our Abacus project, which is basically a calculator, is running on the FPGA. Let's go back and program the flash. So every time you turn on the device, the FPGA will boot up through the QSPI flash, and you don't have to go through the generation of the bit file and programming it through Vivado. So right click, add configuration memory device, expansion, 32-bit is our part number. Let's select that. And note that this will erase any previously loaded configuration file on your flash. So select your bin file, and it has the same date of creation and time as your bit file because they get generated at the same time. Click OK. So it performs the erase operation, program operation, and verification in 3 steps. So the flash programming is completed successfully. And if we go back to the device, the JTAG port is used to talk to the FPGA, and the FPGA will take the bin file and program it on the flash. But for us to use the SPI flash, you need to change the jumper settings. So this time we're booting up through the SPI flash on the Basys3. So change the jumper back and put it in to the QSPI mode instead of the JTAG, which it was previously in. Now if you turn it on, the FPGA will boot up through the flash device, and you don't have to go through the hardware manager and programming the bit file setup. You can see that the LEDs glow and the 7-segment display is ready and running. Have fun with your new Basys3, and good luck.